Hey guys, welcome to another video. So today we start a new set of videos titled the 100 series. Now, I'm quite excited about this because for those that know, right, the 100 is a set of exercises by Jim Coronius, right, relating to the integration topic in 4-unit maths in extension 2. So what I've done, right, as part of my center is that once my students have been given the 100 series for them to do, which is, for those that don't know, it's 100 really nice integration questions with really little guidance, right? You just got to know the technique. So it's really good practice for exams right before an integration exam or your trials, right? Really good practice. But what I've done for my students is I've then created the next 100, pun intended. So very excited to sort of, over the next few videos and lessons, show you questions from both Jim Coronius's original and my next 100. Now, just to sort of give you a visual. So Jim Coronius is 100, right? Old school, very old print. So if you want a copy of that or the next 100 questions for you to practice, send us an email at info@nexteducation.com.au and we'll email back with the papers. So now, what I'm going to try to do is pick maybe 1, 2, 3 questions, depending on how long they take, from either papers, right? And then I'll just do them, right? Show you how to do them, show you the technique involved, and hopefully, you start getting the pattern for some of these harder integration questions. Guys, before I dive into my first example, as always, if you haven't already done so, please subscribe to the channel, tell your friends, and then like the video. Thank you. Let's start this. So this is from the Coronius paper. So looking at that, right, you just gotta appreciate its simplicity for a second, right? It looks okay. Now, first thing you should try to do, right, whenever you do this, maybe try to use U sub, right, or substitution. So if this was, or reverse chain rule, if this was fx, now f dash x equals to, what's that, guys? It'll be -1 minus 2x. Okay, not quite the derivative on top, so it might be a bit painful if I was to do it. But I can make it happen, right? I can manipulate the top to make it look like, sorry, maybe I'll leave that in, make it look like the derivative, so I can reverse chain rule it, right? That's okay. And then split that up and see where that takes me, right? Let's go there. So quite a few techniques involved here, and after this. So whenever you have something like that, it is always useful for you to explore the reverse chain rule, right? So let's see. I'm going to try to manipulate it. So I need this guy to be negative. So I tried to get the 2x in there first, right? So maybe split the fraction first, right? So if I split that fraction, minus x squared, with a 1 there, and then plus, oops. Yeah, so the same deal here with an x, dx. Sorry, I've got a dx there. Now, let's try to manipulate this, right? So I'm going to put a -2 there, which means I'm going to turn this into a -1/2, right? And then I'm going to -1 and then +1. Actually, the +1 should be in there, but that's fine. I'll collect it in anyway. Yeah. Just want to show you technique. This is how I would actually go about doing it. So I won't do anything to the first part, right, for now. I'm just going to copy and paste that. Oops. Don't even need that. Yep. And then we'll see what I have here. So I got -1/2. So break up the fraction, right? The -1 minus 2x, that's integratable, right? Reverse chain rule. And if I have plus, so dx there, so that's a plus, then it's a minus, so -1/2 of 1. So I'm just going to collect like terms, right? So I'll show you what I mean by that. Because right now, that integral looks exactly the same as this one. Right, so what I'm going to do is basically collect this one with this one, right? So 1 minus 1/2, so it just becomes a 1/2, right? So let me just check that. Yep, perfect. Now, so when I do this, I'm just going to copy that. So group the two blues and it becomes like a half in front, right? Okay, now this piece here, that's reverse chain rulable, right? Because the derivative of, okay, so I'll use u sub, right? I'll let u be the bottom function, right? And then I can do that. So just to be clear, what I'm talking about here is if you then let u equal to, sorry, 1 minus x squared, then du dx equals to minus 1 minus 2x, right? Then dx equals to du on 1 minus 2x, sub that into there, sub u into there, and you should be able to do it, right? So that's fine. Now for this one here, guys, technique, right? All about technique. So sine inverse, right? Basically, so I need to try to complete the square with this part here. So let's see. So I go, yeah, I always say to my students, when you try to complete the square, try to make it a bit larger. So factorize the negative out. No, go x squared minus x, also plus x rather. Yeah, and then I'll leave a little bit of space here for me to complete the square. This one here, I'll use u sub there becomes, now the denominator is still there. Sorry, the numerator is still there. Square root now, root u times by du over the same derivative, right? So let me just quickly do this one. That goes there, and then that's integratable, right? That piece there, self-contained, integratable. I can do that. Now, for this one here, I need to complete the square, guys. Now, to complete the square, I need a quarter here, and minus a quarter here, right? Let me just check the maths. Right, perfect. Yeah, let's see. Then I get, yeah, just to be clear, the whole point of that is to give me a perfect square over here, right? And this perfect square is equal to x plus a half squared, right? And that will give me sine inverse, right? Yeah. Now, by the way, I'm going at a pace that's slightly faster than you would normally do it. So can you please watch these videos after you've done the integration topic and you're just at a point where you want to practice, right? Yeah. I won't slow down too much. I do have a few videos on this channel that does integration, especially recurrence and stuff. So watch those. But you know, when you're learning these videos, make sure you're at a point where you've done it all and you just need some practice, right? You just need some questions or some practice. So let's see. This one here now. I'm going to collect the 1 and the minus quarter, also plus quarter, right? So it becomes like 5 on 4 minus x plus half squared. Okay, that is now prepped for you to do sine inverse. This one here, if I bring the u power up, becomes negative, right? Du, okay, that's ready as well. Everything's prepped. So now when I say prepped for sine inverse, we know that a here is what, root 5 on 2. Yeah, and that's the function. And the derivative is upstairs. Okay, great. Right? Everything's ready, right? It's all primed, prepped for me to do my thing, right? So it becomes like half. Now sine inverse doesn't have a fraction in front in the formula. Sine inverse function over a, check that, perfect. And then minus a half. Now this one here, add 1 to the power, divide by new power plus c, right? And the last one, I'm going to do 2 simplifications. Oh, sorry, 2 things. Firstly, I'm going to times top and bottom by 2, so it's nice. And then this one here, just substitute the value of u back in, right? And also the halves cancel out. Yeah. So your final answer times it by 2, you get 2x plus 1 root 5 minus u, which is 1 minus x squared. We'll power a half, so let's put a square root there. Plus c. How's that? Let me just check. Got a minus. Yep, perfect. Guys, how's that? So I like this question. Lots of technique involved, right? Lots of technique involved. The moment you sort of see like a quadratic downstairs and there's a linear function upstairs, reverse chain rule. Try to manipulate so that you can get it and then go from there. Guys, maybe I'll just do one more, right, as an introductory video for this one. Now, Next one, the part of the 100. Guys, this one here, I mean, for those students that been in my class, whenever we see that square root, right? Yeah, this one here, harder trig sub, right? That's the category of questions that I give. Now, there are 3 trig subs, right? Because there's 3 combinations of this, right? For those that have seen this before, you can either get x squared minus a squared, you can get a squared minus x squared, and you can get x squared plus a squared, right? They're the 3, right? And each one of these, pardon me, over the course of the 100 series, I'll go through the integration or the substitution that you need. But for this one, right, for those that know, I need to replace that sec squared minus 1. So so let, now should I use theta? Yeah, let's use theta equal to, so let x equal to sec theta, right? But with an a in front. Yeah. Now, for those that don't know this technique, the reason why we'll let it be a sec theta is because when I sub this into there, it'll be a squared sec squared, factorize the a squared out, and you get in brackets sec squared minus 1, which is a trig identity that gets us to tan. The whole point is you want to create a trig identity that puts 2 terms into 1 term, right? Reduces 2 terms to 1 term. That's the point, right? So once you let that happen, guys, I need to replace dx and this blue highlight, right? So I need dx equal to, now the derivative of sec is sec tan, right? Yeah, d theta. So I want to sub that into there, and I want to sub this into there, right? And of course, sorry, not into there, into here, and here. Let's see where that takes me, right? Let's see where that takes me. So on the top here, I'm just going to put a 1. I'll move the dx outside, right? So x is a sec theta multiplied by root a squared. I'll factorize a squared out, 1 minus, I'm sorry, sec squared minus 1. And then dx, so for dx, it's a sec theta tan theta d theta. Now, let's see. It's actually quite nice, right? Because if you think about it, just this highlighted part, right? What's that? That's going to be the square root of a squared tan squared, which is going to be a tan. Now, why is that nice? Because everything cancels out, doesn't it? Look, I got a sec, I got tan, and I'm left with a, right? 1 on a, which is a constant, right? So left with 1 on a, which is a constant. So you're left with 1 on a, which is constant. So your final answer is just going to be theta on a plus c. Yeah, and how do you get theta? You come back upstairs to your substitution, right? And you basically get it from here, right? Get it from this line where you go sec theta equals to x on a, and theta, let's go cos theta equals to a on x, right? Reciprocate that. Let me just make sure. I guess you can go sec inverse, but I'll do cos inverse instead. So theta equals to, yeah, and sub that in, right? Yeah, so your final answer is cos inverse a on x on a plus c. How's that? Yeah, actually, let's do one more. Let's do one more. I prepared another one. Oh, I have to do the next one. It's my favorite, right? For those that know me, right, I tell people all the time, so that doesn't look like my favorite, but it reduces to my fave, right? For those that know. Now, whenever you see this, guys, just think, right? So I say this to my students, whenever you see trig, right, downstairs and there's a squared, chances are, if there's a squared in the expression, it's identities. If there's no squared, chances are you're going to use t results, right? That's really the sort of, initial test whenever you see a new question. But this one here, you just got to know, right? Like you just got to be amazing at your trig identities. Guys, that is a trig identity that we know, right? Yeah, we know that cos squared minus sine squared is, what is it? Cos double, right? And the double of x on 2 is sec x. Oh, sorry, cos x, right? And because cos x is downstairs, becomes sec, which is my favorite question, right? It's got the biggest hack, that's why. Yeah. So sec x. Yeah, dx. Now, two ways to do sec x. One, you can use t result, and that takes you about 10 steps. Or two, you use this amazing reverse chain rule hack, right? Now, if your teacher hasn't shown you this, please make sure you learn it because it's amazing. What you do is, yeah, you set that as a fraction and you times top and bottom by sec x plus tan x. Yeah, I believe that's in the textbook as well. Now, the reason why you do that is, amazingly, if this now, you're using the reverse chain rule, if this guy here is your function, yeah, if you let that here be your function, off to the side, the derivative, now, the derivative of sec x is sec tan. Derivative of tan is sec squared, which factorizes into sec times tan x plus sec x, which is exactly what's on top, right? So what am I trying to say? If fx is on top and f dash x is there, right? Reverse chain rule, I can use ln, right? That's ln, yeah? So therefore, your final answer is ln of the function plus c. Yeah? Now, in terms of x, perfect. And that's my answer. Guys, so nice. Yeah, so nice. Love this question, my favorite. So hopefully you're enjoying the series, right? The 100 is a really nice revision pack for those that have finished integration and want extra questions to do. Um, they're nice because they're clean, right? Each question is like just one question here and there for you to do. There's no part A, no part B. It's just the question on its own. And it just really lets you hone in on technique. Guys, if you like that video, as always, subscribe to your channel, tell your friends, and then like the video. Thank you very much. I'll see you in the next one.